Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT ONE, the consultancy that specializes in supporting digital transformation of operations and businesses. Our guest today is Luca Rossettini, CEO of D-Orbit. D-Orbit develops solutions that enable the optimization of operations for satellites, orbital transportation, space logistics, and space waste management. In this talk, we discuss the rapidly evolving space ecosystem and the challenges being created by an explosion in satellite launches. We also explored how data provided by satellites will increasingly drive business innovation for a wide range of industries from shipping to farming. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, please email us at team@iotone.com. Finally, if you have a business challenge and would like to discuss how IoT ONE can support, you're welcome to email me directly at erik.walenza@iotone.com. Thank you.
Luca, thank you for joining us today.
Thank you very much. It's a pleasure and an honor to be here with you, Eric.
So, Luca, this is a super interesting topic to me. We're going to be talking about the status of the space sector and logistics in space. This is a topic that I know very little of, aside from YouTube videos educating me. So I'm personally interested in getting an education here. But before we get into D-Orbit and your business, I'd love to understand a little bit more about your personal path and how you ended up founding D-Orbit. Maybe you can start with what was the first touch point between you and the space sector? Because I imagine not many people actually make it into the space sector, right? There's got to be a bit of a backstory here.
Yeah, so we need to go back a long time ago when I was 5 years old. So my first step into space was when I realized that there were stars on the sky, and I want to go and check them out. And I was 5 years old, and then at that point I decided I wanted to become an astronaut, as many kids, right? But that actually was very important because I built all my personal roadmap and even professional roadmap in order to get there. I study engineering, PhD in advanced space propulsion. I also joined the Army, and I served as a parachuting officer for a couple of years here in Italy, and waiting for the astronaut contest in Europe. And in Europe, you have pretty much one chance in a life. So you know that when the contest is out, you need to do all in. So basically, you have one chance. So that's why I went through this roadmap. And let's say, like in the making, while I was building all these competence, I had the chance to build another couple of companies. And the main reason, again, was because having a company, I could sustain my studies. For example, I could pay for my PhD, and at the same time having flexibility to prepare for the astronaut contest. The first company was providing, so we were building drones when drones were not cool, so a long time ago. We were providing services using big drones for the industry. And the second one that actually was very interesting, we were providing special effects for the movie sector. We even went to the Oscar with an Italian movie, the Human Capital. We didn't win the Oscar, by the way, but it was really, really an amazing experience. So let's say all my background was built in order to get to space. And once the astronaut contest came out, and of course, I didn't win I'm not an astronaut. At that point, I had to decide what to do with my life, because as I mentioned, I made all in for this. And I was lucky enough to win a Fulbright scholarship. I flew to US, I studied business there. I worked at NASA where I met Renato. And then from there, we decided to start the D-Orbit in order, sooner or later, to give the possibility not just to astronauts, but to everybody to make business, travel, and have a living in space.
Okay, yeah, fantastic journey. Well, I have a son that's just about 2 years old, and he loves the stars and the moon. So I suppose I should start encouraging him now, see if I can plant that seed. I'm just curious. So the astronaut, I see on your LinkedIn profile there were 10,000 candidates for the Astronauts Corp, and that you ended up being among the top 200 candidates in selection. How many were actually selected? Are we talking about 5 or 50? What's the actual number that they select out of this 10,000?
4.
Oh, wow. Okay.
Yeah, but I remember when I was at the last phase of the selection, I mean, around me, there were like really amazing people. I mean, jet pilots speaking 6 different languages, people who literally lived within volcanoes or like in the Antarctica. So really edge people. So I think it's really a very tough competition, and only the best can make it. Well, I just found another way to get there using a different roadmap.
Yeah, no, absolutely. And hopefully this roadmap will make it easier for everybody, as you said. So instead of 4 people, we can really have thousands going into space. Let's then get a little bit into what D-Orbit does. So before we get into the technical details of how we actually enable logistics in space, what's the value proposition behind the company? What are the problems that you're solving?
Yeah, so first of all, we want to build a space logistic infrastructure to enable not just a space economy today, so not just helping the satellite operators to do a better job, improving their revenues and decreasing their costs, but enabling the entire human expansion in a sustainable space. This is what we want to achieve. What we do today with the first service, that is a satellite transportation service, we allow satellite operators to save up to 85% time from launch to operations. So basically, they can start making revenues just a few weeks after the launch. And the other value is that we decrease the cost of launches. That is one of the most important costs in the space sector by 40%. Because with one mission, we can go pretty much everywhere. So we can even go in locations in space that were precluded before, and for which the only solution you have today is to buy a dedicated and very expensive launch.
Got you. So if we think at a high level about the costs involved in space, then would there be the cost of launch, the cost of the hardware itself, let's say the satellite, and then the cost of operating this over a number of years? Is that kind of the way you think about it? And then if so, how do we divide those up? If we were to divide those into 100%, what would be the cost today?
Generally speaking, like a space mission, as you mentioned, is like 3 factors. So the launch, the manufacturing of all the hardware, the satellite or the payload that you need to bring to orbit. And the third one is the operation. So all the effort that you need to put to control and drive your satellites in orbit and download the data, process the data in order that you are able to sell the information. This is how like a space mission works. For the orbit, it's, the 3 areas, the 3 costs are pretty much the same, but on the last one, we don't produce data and applications for the Earth market. Our, let's say, operations are mainly related to serve the customers that are already in orbit. So to provide them services that, as I mentioned, you can go from transporting a satellite of our customers from one place to another. We can also test technologies for the early stage companies that they still need to get the proof of concept. And we can do it very quickly we don't let them pay, like CapEx. So they just pay on a monthly basis. And we can even deliver like edge computing in orbit in order to maximize the number of information that our customers can download and therefore sell. And then you can name it and you have it. So you can add on top of this infrastructure that we are creating several other services. Most of them, by the way, are suggested by customers. So customers are telling us, what about or what if? And we say, wow, that's really great. Definitely we can do that.
Okay, so you're not building the rockets that are taking objects into space. You're building, if I have it right, you're building kind of a delivery mechanism that can then more cost effectively deliver the satellites once they're in space into the right orbit, and then provide services around that? Or can you just give us like what let's say the product portfolio that DR Orbit has in the market today?
To answer to your question, yes. So we are complementary to launchers, to the rockets that go into space. We are compatible with all the existing rockets that are already in service today. And we are also talking with the newcomers, the launchers that will be in service in the next years, in order to make sure that we are compatible to each other. But for us, it's like launchers companies are partners. So they provide the first step to orbit, and then from there, we take care. So if we think about the contribution of the orbit to the space sector in terms of products and services, the first one, definitely when we started the company, was related to space debris. When we started the company, space debris was not even an issue for industries at that time. It was a well-known problem. So space pollution was a well-known problem for academic, but not really for the industry. Even at the space agencies, there were not really programs running at that time. So we believe we contribute to change a little bit this mentality, to accelerate the process. We were not the only one, luckily, but definitely our products was a system that allowed to remove satellites at the end of life, even if the satellites are not working anymore, definitely change the perception, and it showed that it is possible to do something about space pollution. And then we start building satellites. We usually don't build satellites for third parties. We have partners that are satellite manufacturers. We usually refer to them. But if a customer requires some special hardware capabilities, since we verticalize everything, we build from the electronic board to the full 500 kilo satellites directly in-house. We can do that. We have quite a lot of patents on satellite components that are very useful for those that are thinking to build satellites in the, let's say, size of few hundred kilograms. Very reliable, and especially we use the NASA and ESA, the European Space Agency standards, in order to make sure that the quality is very high, although we use low-cost components. So let's say that the costs are reasonable, but the quality is high. And then we go to the real core business today, that is transportation of satellites, delivering service in orbit. So in orbit, demonstration and validation of hosted payload. As I mentioned before, edge computing. And we are preparing to enter in what is, we believe, one of the biggest market for the space sector, that is the in-orbit servicing, in which we will tackle the issues of extending the life of satellites and what is defined as active debris removal. So again, going after satellites that are at the end of life and making sure that they create no damage to the satellite operators and no reduction of revenues, or a damage to the entire space ecosystem.
Yeah, no, I understand that SpaceX and some other satellite operators are planning to put really tens of thousands of satellites in lower Earth orbit, right? So that's going to be a monumental challenge to keep clean. It feels like it's a little bit of a land grab, right? Because it's kind of first come, first serve. So you might as well just get your satellite there and then you control that orbit. How do you actually do? So let's say there's a set of satellites that are near the end of their life. Is it that you have some kind of laser device that would subtly change their orbit and direct them into Earth in such a way that you're confident that they'll fall into the ocean as opposed to on the landmass or something? Or what is the process of cleaning up space debris or satellites that are at the end of their life? What does that actually look like?
Yeah. So there are several strategies, and first of all, an important aspect is that the sector is heavily unregulated on this topic. So an important part, and many industries that are willing to enter into this market are also working with the regulatory body. The important step is to define rules, right? So you want to make sure that all the investments that the industries are making are relevant and are not really going outside of what the rules are going to say in the future. So space traffic management is another big topic. But anyway, so we use a very logical concept. We say, first step, whatever you send in space today, you want to make sure that it will be removed immediately when it's not useful in space anymore. That is quite logical. So we have a product for that. It's called D3. You install it on the satellite before it goes to space, and it's capable of removing a satellite in low Earth orbit in like 90 minutes if you want, even more. But let's say the minimum is really 45 to 90 minutes. So basically immediately. And this will stabilize the issue because no more debris is going to be generated from new satellites launched in space. Of course, if you have a large constellation and you are operating at an altitude for which it will be expensive to have all the satellites with a heavy system on board, this may not be the best strategy alone, but then you can go for a hybrid strategy. So you use a smaller version of a D3 that will enable satellite operators just to remove the satellite a few kilometers away from the constellation. So you avoid collisions with the same satellites in the same constellation. And then you use the active debris removal service that, of course, is not yet in place, but it's going to come from the orbit or maybe other companies. There are very good companies that are working on that as well. And most of the technologies that are used for that are based on robotics. Yes, you can use lasers, but it takes a lot of time, and time is a very important value for customers, for commercial companies. So I do believe that robotic technology will be the best because it's the fastest. So you go, grab the satellite, and then you remove it. We have a special, strategies to do that are based on the concept that we are working since 2015, long time ago, when even the in-orbit servicing was really a concept at that time. And we plan to do it in a way that you can serve many different satellites with just one mission. In this way, you ensure that the cost for customers, so the price that you are selling the service to, is reasonable and affordable, even for these very large constellations in low Earth orbit.
Got you. So how has I have some statistic in my mind, which is that it costs something like $10,000 per kilogram that's transported to space. I don't know if that's true or one that, that might have been 10 years ago, but how has the cost structure evolved, let's say, in the past decade? And where are we today in terms of the cost of moving mass into space?
Today, you can spend as low as $5,000 per kilo. Of course, if you have a small satellite, you don't have access to that price. So you need to have a certain mass in order to have access to that. In general, the price per kilo went down a lot in the last few years. And now you have two scenarios. So you have big rockets, big commercial rockets that are really driving down the cost per kilo. If you take SpaceX, it's $5,000 per kilo. Then they are already talking about Falcon Heavy that is lowering down to less than $2,000 per kilo. And then, you can go on the Starship and so on. So like big rockets are driving down the cost more and more. Of course, in order to have access to that, you need to book a minimum number of kilos. On the other end, you have micro launchers. These are very small launchers. They have the capability of lifting a very small amount of payload, but whenever you want, and they can go in a very specific orbit. On the other end, the cost is definitely higher than that. So 10,000 is the minimum at the moment. It is possible that in the future there will be micro launcher reducing this number. We should remember that a rocket is made, let's say, 90%. Actually, a micro launcher, probably 95 to 98%. It's made out of metal and propellant, right? So it's not really the payload. The payload is what actually pays back all the investments done. So the flexibility of smaller rocket is definitely less, But the advantage that they offer is really the flexibility of getting ready whenever the customer wants. The big rockets, they are less flexible, but they can really allow you to save a lot of money. If you put together the two, so micro and big, and you add on top a logistics service as the one that we are providing, basically you ended up in a framework for customers that they are really, that it's fully transparent, and they can really decide, I want to spend less, or I want to be there tomorrow, or I want to be multiple locations within 1 month, and you play with all the players, let's say in the rocket industry, in the space logistics industries, in order to make it happen, providing an end-to-end service.
Okay, got you. So you use the heavy launcher the heavy rocket to get into space, and then you use some kind of some distribution device to then distribute the satellites into the particular orbits once it's in space. You get kind of the best, you get the low cost plus the accuracy. Is that kind of the value proposition here?
Well, yeah. So you can do that, but you can even so customers coming to us, sometimes they say, we need to send in space 20 satellites in the next couple of years. So we ask them, okay, why 2 years? Is this the issue? Because you don't, you just have the satellites ready in 2 years? They say, no, well, because launchers are not so frequent and all these kind of stories. Okay, let us work on that, because we can put together big rockets with our cargo on board, and we will take care of delivering satellites in all the different locations. But we can use at the same time also smaller rockets for dedicated number of satellites that will be directly injected in an orbit. And by the time that these satellites get into position, because there will be not a cargo on that case, all the other cargos will complete the mission. So in way less time, you have the constellation, the 20 satellites already positioned in different locations using a mix of, let's say, launch providers. This is pretty much similar to what is happening here on Earth. If you look at the cargo boats, they have a lot of containers in it, but they also have small vehicles like post office trucks, right? So in which you put the small payloads, the small packages. So when the boat arrive at the harbor, most of the containers will be managed in the standard way, but then the vehicles switch on the engine and they start traveling around to deliver the package. So you use different type of logistics services to accomplish the final goal. And this is the beauty of logistics. It's an infrastructure that you can use basically to accomplish pretty much all your objectives, and you can use a diversity of providers and services in order to get there.
Understood. Okay, excellent. So we're moving from a situation where it's a few governments in the world and a few very large companies that are active here, and they're not so price sensitive about this. They're really working on a project basis, towards now more of a typical business environment where you have a lot of players of different types and they're trying to do things efficiently, and you're bringing kind of logistics best practices to the space world. Can you explain? Maybe I want to get into some of these topics about edge computing in space, but before we go there, just to take a step back, can you explain how is this relevant to me? How is it relevant to a shipping company or a farmer in a remote location? I mean, why is this kind of this boom in productivity in space important for people that are not directly in the industry?
Yeah, that's a very good question. Actually, this is probably the first question that should be asked to any space guy, right? So so why are we investing in space? Basically, what is the return on the investment for us that we are living on Earth? Well, so let's get a look at what is happening on all the industrial sectors on Earth. They are all growing, moving towards digitalization, industry 4.0. They are all using big data. They are all using informations to take decisions that are based on added value data. And all this data, the added value data, most of that are coming from space today. Like agriculture is becoming agritech, finance is becoming fintech, automotive is becoming autonomous driving. So we are really changing the way we do business here on Earth. And what is the most scalable way of getting data is definitely through satellites around the planet. I give you this example. Let's take internet. So the best technology on Earth today is the optical fiber, right? So with the optical fiber, you can have an amazing internet connection. However, if you are a company that is deploying the optical fiber, then your market is one city. So you deploy the fiber, then you start selling, then you want to expand it, you go to another city, then you have to deploy the fiber. And when the fiber becomes obsolete, then you need to take away the old fiber and put the new one, and so on. If you have a constellation of satellites, your market is the planet Earth. So the maximum scalability. And when the technology will be obsolete, so the 4G is obsolete and now we have the 5G, well, the new satellites that you are going to send in space, you just equip them with the new technology. So you will always have up-to-date technology ready to serve the market. What is the main consequence for us? Well, first of all, everybody can have access to internet. So 2 billion people are not connected to internet. And there are still people that are not even connected, they don't have a phone line. Okay, and this is let's say inclusion, and it's a very important goal. But also in terms of cost, because if you have like in a global coverage, these companies can have access to way more markets, and they can mitigate the cost impact of the constellation over a way larger market than you can have with the optical fiber system. So this is also going to reduce the cost for us, and reducing the cost will increase the capability of generating new business models here on Earth using satellites data. And this is just one example, but I just want to make this another example. It's a funny example. It's something that I learned only a couple of months ago. There is a service for fishermen, so that tell them when to go out in the sea with the right weather conditions, where to go and fish the mussels at the right ripeness level, and when to sell them into the market at the highest price possible, crossing data from weather forecasting satellites, Earth observation satellites, and the stock exchange data. And this is really a good example to understand how today is possible to generate services that were not possible to think about just a few years ago. And today it is possible thanks to this enormous amount of satellites that can generate data to deliver this type of information.
Okay, fascinating. I know that SpaceX and other companies have solutions now. They're at least piloting solutions for providing internet connectivity to remote regions. When would you expect this to be kind of achieve price parity? I mean, I guess it obviously depends on the region. So maybe for a rural farmer, it's the only option, maybe. For a lot of situations, I guess people say, well, we already have fiber. We're in a city, we're in an industrial park or something. Do you expect there to be a time when satellite, in effect, replaces? Or will it always be a kind of a portfolio? We use fiber when we're in dense urban areas, and then we use satellite for rural areas, suburban or open seas, etc.
I'm not an internet expert, but let's say if we look at what happened in the other markets in the past, there will never be a black or white situation, right? So you will always find coexistence of different technologies, because there will be niche utilizations of each of them in all the situations. But I'm expecting that more and more internet from satellites will be, let's say, dominating the market, while all the land technologies will change the way we consider them. It's pretty much like, if I look at what is happening in the energy sector with the renewable energy source, like the solar plants, wind plants, and so on, you see how the managers of the networks that before were also the source of energy, now they are becoming, let's say, really the manager of the network. So they are connecting different sources and making sure that all the the proper mix of energy reach the end user. I'm expecting that the internet infrastructure on Earth will become something similar. So there will be companies that will be transformed into infrastructure manager. They are going to manage the different source of internet, from satellites, from fiber, from like any other technology that may come up in the future or is already existing. So this is what I'm expecting. And more, we are transitioning from like product to service, right? So this is already happening on Earth. And the same is happening in space. So that's why, in our case, we are focusing way more on services rather than selling our platform. That, by the way, they are good platform, but most of the value is really coming from the service.
Gotcha. Okay. I want to return to this topic of edge computing just because I didn't fully understand what the application was there. So for edge computing, is this a set of technology that you have that you would deploy on satellites so that they can pre-process data before sending it to Earth in order to reduce costs there? Or is it communication between, like providing an infrastructure to communicate between satellites? What would be the application for edge computing in space?
Yeah, it would be a step-by-step approach, but let's start things to understand why it is an important service. The first answer, if you look at why a cloud services and edge computing is important on Earth, we understand why it will be important in space. But in any case, a satellite can generate like an incredible amount of data in like 90 minutes, right? So, but only a small portion is downloadable, because you just have some visibility windows in which you can download the data, and you have a limited bandwidth. And the smaller the satellite, the smaller the bandwidth. Once you download the data on Earth, a portion of that data, and you can go up to 70, 80% of that data, is not usable because it's not good data. So you have to waste that data. Then you start processing the data to extract information that you want to sell to your customers. And another like 5 to 10% is lost during the processing. So you ended up with just a small portion of what you can really generate. If you have the possibility to transfer all the activities that you are doing today on Earth into orbit, you have access to like an incredible higher amount of information. You can download directly the information that is ready to be sold to your customers. So for a satellite operator, this is really a game changer service. The way it works, of course, you need to go step by step, because today satellites, most of the satellites don't have interlink, so the capability of connecting with other satellites. So you need to rely on what they have. So the way we work, we have a core technology that has the capability of running artificial intelligence algorithms that we are developing, should be ready next year. You can install directly on satellites, so they are already autonomous performing these operations. But of course, this is limited. At the same time, we are also testing in orbit, and this is going to happen this year, a real edge computing, providing this service to some pilot cases. In this case, we will use, let's say, standard technology for communication, but the next step will be the optical communication. So now you can elaborate the data in orbit, so you have the information, but you still have a lot of data to download, and you are still limited by the regular radio frequency limited bandwidth. What if you can use laser communication to do that? If you pair the two, then you ended up in the best service that you can provide. So as I mentioned, this is of course in the making. Some tests will be done this year. Some service will be available next year, and so on. But this is definitely going to improve the capabilities of satellite operators to provide a better service to their customers. And at the end, it may also allow them to lower the pricing for their end users, providing a benefit to all of us here, again, to our society.
Okay, clear. Interesting. To make this all a bit more tangible, could you walk us through a kind of end-to-end case of one of the customers that you're supporting and how specifically they're using your solutions?
let's take an example of a satellite operator. I will not tell you the name of the customer, but I will use pretty much real data. So this customer has a constellation of small satellites. These satellites are 3-unit satellites. So they are small satellites, 30 centimeter by 10 by 10. So real small satellite for Earth observation. And they usually have these satellites located in different orbits. So the use case here is to make sure that they get the satellites in their position as soon as possible. How we do that? We put together satellites in more than one cargo, in multiple rockets. So not just one rocket, because we want also to mitigate the potential risk of failure of the rocket. Even if you divide the total satellites in more rockets, using our service, you are still saving up to 85% time. Once you get to orbit, our cargos move into the 4 different planes in which these satellites need to be placed. And once they reach the planes, they also perform what we call accelerated phasing or accelerated deployment in order to make sure that the satellites, once delivered in orbit from the cargo, are exactly where they need to be and they can start operating immediately. And all these operations is done in a few months. The value for each satellite, so let's take into consideration the same satellite operators going to follow the business as usual, traditional way. They go to a launch provider, they just buy the launch capacity, and then they need to buy several launches, and they need to wait to get into position, okay? You have delay on the launchers, you have a delay on the revenues, you are, in any case, burning cash in the meanwhile. You have a reduced life of your satellites because a portion is used waiting to move from A to B in space, so less revenues. So if you put all together the value, the economic value for those satellites, for each satellite is between 2 and 2.5 million that you can get. And of course, you are paying a fraction of that just to complete this mission. This is a very interesting use case based on real data, and the value for customer is real. And we have a tool to calculate the value for customers that we usually provide to customers. They can fill it up on their own, so we don't have access to their information. And they ended up receiving a report with the value of all the maneuvers and all the scenarios that our algorithm generate for them in order to optimize based on their requirements.
Okay, very, very interesting. Yeah, it's so just capital optimization to some extent, right? In time, and I can see how the business case would be fairly clear here, right? All the variables are more or less known.
There is also an interesting aspect that we were not thinking when we start providing in-orbit validation of hosted payload service. Investors are interested at this service. And we learned that venture capital investors giving money to a young company to develop a technology, of course, is taking a very big risk, because if the technology doesn't work or is not able to get to market, they basically wasted the investment. And one of the barrier today for those companies is really to get to space as fast as possible to test their technology. However, today it takes between 2 to 5 years and $2 to $6 million to get there. So we started this service back in 2017, when we launched a satellite with on board 3 customers. It's very interesting because now we have venture capital funds that are contacting us saying, asking, we have three companies in our portfolio. They develop this and this and this technology. We would like to accelerate the go-to-market. So we will need a proof of concept, like a validation in orbit as soon as possible. We are willing to make an additional investment if the technology is successful. Can you help us to make sure that it's going to happen in the next few months and not in 2 years in the future? And that's really, how an infrastructure is different from just a product or a service. So the infrastructure can be used by multiple different users, and they can even come to you with different needs and, suggest you new services that you can deliver.
Just so that I properly understand, I guess there could be two ways to accelerate time to market here. One would be that you use your infrastructure to accelerate their satellite going into space so that they can start collecting data. The other alternative I could see would be that because you have the infrastructure of knowing what satellites are in space, what data is being collected, you might be able to say, we can get you the data that you would need to at least make it kind of run a pilot and make an initial assessment of whether the value proposition really exists. And then if so, then you can actually launch your satellites. Is that typically an option, or is it usually the case where they would actually have to launch their satellite into space? I mean, is that something that you would provide to say, maybe we can find you the data from an existing constellation, at least as a pilot or a proof of concept?
Let's be a little bit more detailed on this. I realized that I didn't really explain how it works, but you are right. So you have let's say you are a startup, you develop the best technology to deliver information to the agriculture sector. So you have this device that is capable of, taking very special pictures of crops. But you need to test it, and you want to build your own constellation. So the investors gave you, like a few millions to develop this technology, but then you need to go to the next step. You go back to your investors and look, we have the technology developed, and now we want to start building our constellation. And I need, like 60 million to start the constellation. And the investors, of course, will tell you, well, I want to see that this is working, and I want to see some customer happy before giving you such a lot of money. So this is where we enter into the equation. So this company can come to us. They can install their payload in our cargo. In fact, every mission we have some of these technologies on board from different companies. And once we get to orbit, we deliver first all the satellites that have the highest priority. So the first customers are always satellites to be deployed. Right after, we start testing the payloads, so this technology for these companies, providing real data from space in a real mission that they can also use with initial customers or to run their own pilots. So not only they validate the technology in orbit, but they validate the business model, and they can interact with customers at the same time in a fraction of the time. They don't need to build their own satellites now. They can get immediately to the results of their technology, and then they can go back to the investors and really start building their constellation step by step. So we are a gap filler, basically, in this case, right? So we help them to go to space. Of course, if they are successful and that technology that we successfully tested in orbit is going to become another satellite constellation, at that point, we will have a good relationship with that customer. If the customer is happy about our service, as we understand many of our customers are, we are expecting that companies will come back to us to launch their satellites in orbit as well.
Understood. Okay, yeah, thank you for breaking that down. Luca, I think we've covered a lot of ground. There's one question which is a little bit out of scope here, but I'm still quite interested in your perspective. You are clearly passionate about this topic. When do you personally believe that you'll be first in orbit? Do you see a timeline where you're going to see yourself in space in the next decades?
Not an easy question, although I would like to answer as soon as possible. So there are two ways to get to space today. You pay a ticket and you go to space. Definitely SpaceX is working on that, and they will likely to be among the first to allow, let's say, other people to fly in space. If we check what the orbit is doing, so our approach is a little bit different because we move from market to market. So we want to make sure that we are always working on a solid base in which the market is real and we can sell our products or services. In the orbit, we have this saying that say we use the brain more than the wallet. So we need to make sure that whatever we do, it's capable of sustaining the company. If you work in this way, then you need to follow the market trends. And you need to, first of all, to understand which markets are coming after, and then you need to be ready to get into that. So defining a timeline, it's way more difficult because you cannot say to develop my spaceship, it will take, 5 years. So in 5 years, I will be in space, because you don't know how long the market is going to take to be fully developed. But in any case, since if you look at the trends, everything is moving exponentially in space. And when you play with exponentials, you really understand that our perception, if you look at the past, what happened in the past in the space sector, it will happen way faster in the like now. So I'm expecting in the next 15 to 20 years that we will have cargos flying, moving raw materials and goods from one location to another, and people as well.
Okay. Yeah, I guess once you're moving enough mass through space, then putting a little bit like other transportation models, putting a human into that while you still have life support and so forth. So that adds some complexity, but yeah, it becomes a bit more feasible. Do you think, what does it have to get to, like a price point of 10 million or something like this before, I guess, determining what the actual market size and demand is quite challenging here. But what would you see as kind of a threshold? Would it be like 10 million and that's where you say per person, or 50 million where you'd say, okay, now we have potentially enough market demand to sustain a proper industry?
I remember that my first PC cost me $4,000 at that time and was not even the highest price, right? So, and now you can buy a PC for a few $100s. So at the beginning, in the next few years, and I'm really referring to those that are already testing a space vehicle with people on board, in the next 5 years, you will have the chance to buy a ticket and fly into space, but it will be very, very expensive. So it will not be a service for everyone. And then more players will arrive in the market with probably even better technologies to reduce costs. And at the end, this will become affordable by many. The real question is, are we all ready to fly into space? Because even in a space company, not all the people, although they are all passionate, they are all committed to have an impact in the space sector, not all of them really want to get to space. So for those who want, the price will be lower and lower in the future. It will take a while. It will not be immediately available for everyone. And for those who are in a hurry and they really want to get to space in the next 5 years, then of course they need to be ready to have a very large wallet in order to pay for that.
Clear. Luca, super interesting conversation for me. So is there anything that we haven't covered here that is critical before we call it a day?
I think we covered pretty much everything. Just like a concept based on our experience. So we are among even if we are still a very young company, in our market, in the new space market, we are a sort of veteran. So we started the company when the new space was not even in the dictionary at that time. It is important in this sector, of course, to focus on the business, on delivering value to your customers, but it's also important to have an impact overall on the entire space ecosystem. Because if the space ecosystem will keep growing, all the companies in the ecosystem will keep growing. And this is an important message. So we are already talking with many different companies in the space domain to make sure that we are all aligned, working together to help regulatory body to have a good direction that is good for institutions, but is good for industries as well. And we need to be one voice in this. Our contribution to the creation of the new space market, for example, I already mentioned the space debris product. We were really among the first companies to work on that. Even if we were a very, very small company at that time, the ideas that we throw on the market and the products and the services help institutions to define new drivers for regulations. And I'm very happy to see that this is still moving in a more and more precise regulatory framework. And now we are in the space logistics. So the Orbit was the first company to introduce the concept of space logistics. And we are already delivering the service. At the moment, we are the only one. We will not be the only one soon, hopefully. So this is going to become a real market, not just the Orbit monopoly. But even in this case, we are doing something that was not done before, like moving into different locations. So you have frequency license, you have transportation, you have space traffic management. So you have a lot of aspects that you need to make sure that you want to cover. So providing a contribution, all the companies providing a contribution to make sure that whatever we do in space, we will keep the the space ecosystem from one side growing and from the other side sustainable, so capable of future. This will have a benefit for all the companies working in space, but especially they will multiply the benefits for all of us here on Earth that will, get all the services from space.
Yeah, no, that's an excellent frame of mind for any market, but I can see why it's particularly necessary for this kind of rapidly emerging market of space logistics. Luca, if any of our listeners are interested in learning more about D-Orbit or getting in touch with your team, what's the best way for them to reach out?
Yeah, you can visit our website. That is dorbit.space, or you can write directly an email either to the email that you find on the website or to ceo@dorbit.space. And I will do my best to provide you an answer in the shortest time possible.
Wonderful. Well, Luca, thank you again for taking the time to speak with us today.
Thank you. Thank you very much. My pleasure again, and thank you for the opportunity.
Thanks for tuning into another edition of the IoT Spotlight podcast. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, please email us at team@iotone.com. Finally, if you have an IoT research, strategy, or training initiative that you would like to discuss, you can email me directly at erik.walenza@iotone.com. Thank you.